Hello again and welcome. One of the most frequent questions I get asked is what meter I would recommend. And of course I make a point of not making recommendations, and that's mainly because I really don't know what people's needs are. I don't think without the person asking the question supplying a lot of details about what their requirements are, anybody could actually answer that. Of course I make all the data that I collect from these meters available for free, and you're certainly free to browse that information and see what meters hold up the best in my tests. So when I started out, vacuum tubes were still pretty much the thing. So we had black and white TVs that I would play around with. I started with electronics at quite a young age. I think maybe, 9 years old or so, I started getting more interested in it. And somebody had given me a vacuum tube voltmeter. It wasn't this particular one, but it looked very similar to this. I think it might have been sold by Heathkit. It didn't work. It seems like it could read voltages maybe, AC and DC, but I don't think a lot of the other functions worked with it. But that was my meter up until the time that I turned 13. So this is a picture of me with my fuzzy hair. And it's a little difficult to tell, but in the lower left-hand corner, this is my birthday present. And this is a Radio Shack model 22-204A. This is an analog meter. It's very similar to something like this, except this is actually quite a bit nicer probably. This does not have the range doubler. There's probably some features that the Radio Shack meter had that this one does not, but the quality of the case, at least as far as the plastic, I'm sure the meter movement is quite a bit better on this meter than it would have been with that Radio Shack meter. So I had that Radio Shack meter into my early 20s, and then I bought my first digital meter. I've said it before that this Harbor Freight meter is probably better than my first digital meter. This meter is available for free from Harbor Freight. You get a little coupon and you make your purchase, and then they'll give you one of these meters. This happens to be the new style one. I've used this in a few videos. It still works. So what would you think if I told you this meter was worth $1,522? Because back when I bought my first digital meter, that's about what it would cost in today's dollars. And of course you've seen my digital meter. I've shown it in quite a few videos where I've blown this thing up. You can see the manual date on this is 1976, revision 1. Serial number off the meter. This one is actually quite new. Here's our certificate of calibration. And this is what the meter looks like. And we can see the serial number on this one starts with a 29. It's also marked up on the top, number 29. So I acquired this meter from a friend of mine who used to be a technician at Western Electric. He had a neighbor who had a son who was in the Air Force, and his son had came home and he gave him this meter. It was brand new, still in the box. And of course his dad knew my friend, and after some time he got in touch with him and said, my son had given me this meter. He really didn't have a use for it, but he knew my friend was a technician, so he thought maybe he knew of somebody that would want it. So this friend of mine got in touch with me, and I took a look at it, and I ended up buying the meter. So if we have a look, this is a January of 1974 Popular Electronics. Cost 50 cents back then. Here we can see an ad for the meter. Think of it as the best tester in your bag. Only $299. So if we calculate the interest rates on the $299 in today's current market, that would be $1,522 for this particular meter. Now you can get a high performance model 8000A digital VOM from Fluke, America's foremost maker of quality digital multimeters, especially designed for TV, radio, stereo, and audio services. No other digital VOM gives you the resistance range to check breakers and switches in high resolution voltage, to look at emitter base and other transistor voltages. Excellent AC accuracy and a full accuracy with a 30-second warm-up. It measures in 26 ranges, 100 microvolts to 1200 volts, 0.1 microamps to 2 amps, and 100 milliohms to 20 megaohms, with a basic DC accuracy of 0.1%. Has a full year guarantee, low printer output, deluxe test leads, high voltage RF 600 amp AC current probes, carrying case and rack mount. Unique self-zero eliminates the offset uncertainty. Electronics securely mounted in a high impact case. Service centers throughout the US, Canada, Europe, and Far East for a 48-hour turnaround on repair. So these meters were very expensive when they were first released. So after I had this meter for several years, I ended up damaging it. From what I remember, it took out U3 here and maybe an op amp that was in the same area. So they sent me out a kit that came with all these resistors along with the IC and maybe that op amp, I think a U2 probably. And that kit to do the repairs cost about $75, which in today's dollars, that's a fair amount of money. And then several years later, I damaged it a second time, and at that point there was no parts available to repair it. So I ended up keeping the meter, but essentially it was scrapped. And the real problem with this meter, here's our input. There's basically no protection on this at all. And you can see that some of these pads, like here's our volt ohm input, you put the meter into a certain selection, you could pass this right through, right into this A to D converter. So what ended up happening in my case, it's not like I was trying to use this thing on AC line voltage. That's not something I would have ever done anyway, but I was experimenting with electronics, and you know, of course that included inductors, and in both cases I had some kind of a back EMF kick and it took out the meter. And that's why I'm so sensitive to testing these meters that I have. Again, people equate some of these tests that I do to AC line transients, and I said several times that, you know, there couldn't be anything further from the truth. All the testing that I perform is very low energy compared to what could be available on the line. So I'm more concerned if the meter can just handle some real lightweight transients like what took out this particular Fluke meter. After I damaged this meter the second time, I ended up buying an HP 3468A, and I still have that meter today. It still works fine. I've been very happy with it, and I later bought a brand new 34401A, which I also still have today. So I always thought I'd do something with this meter because the case on this is in pretty good shape. You can see where I melted it with a soldering iron right here. It's got some scratches, but overall it's in pretty good condition. The lens is pretty clean, but again, I had this meter basically brand new. While I did use it, it never really got a lot of mechanical abuse. So with eBay being what it is today, I thought what I'd do is try to find some of these meters and see if I could find enough parts to put this thing back together. So this meter had a lot of damage from running all those transient tests, but I was able to find enough parts to do the repairs. So I thought for fun today what we could do is compare this Fluke against this free Harbor Freight meter. Neither one of them have any input protection. The Harbor Freight meter, of course, has this transistor checker, which the Fluke does not. It also has this battery test mode, which again the Fluke does not. Of course, my original Fluke doesn't use the shrouded connectors that you would see in a modern meter. So with this meter, you'd have connectors like this. This is an old set of Probe Masters. Again, these have a very nice silicone lead. When I received that first Radio Shack analog meter, at the time I was playing around with CB radio, and then later on I got my amateur radio license, but basically everything I was playing with at that time was still vacuum tube based. Of course, as the years have gone by, my hobby is kind of advanced, and so is my requirements for what I need out of a multimeter. And really that 3468A that I bought from HP, that really opened up a new level as far as what I could do at home with my hobby. So something like this may not be adequate as you start to advance, and then that's why we start looking at meters like this. So this Bryman BM869S, I'll still tell people this is my favorite meter. One of the reasons I like the meter, first of all, it's quite robust, but it basically has a high enough resolution and accuracy that I can use this thing for a lot of advanced electronics like I do at home now. So for me, this has actually been a very nice meter. So let's go ahead and turn it on. And let's start by looking at the DC voltages. So we can see the Fluke is a manual range, very similar to the Harbor Freight meter. So let's start with our Harbor Freight meter, and we'll just apply our 5-volt signal. And there you have it, so 5.01 volts. And for this we'll have to set this to the 20 volt range. And there you have it, so 5.00 volts. Let's just switch this to AC plus DC. So again, this is switching between 0 and 5 volts, and it's doing that at roughly 60 hertz. So this should read 2.5 volts. And you can see the Fluke is dead on. Try the same test with our little Harbor Freight meter, and you can see it's dead on as well. Let's just increase the frequency to 120 hertz. And you can see the Harbor Freight is still reading 2.49, and our Fluke should have more than enough bandwidth. And again, we can see 2.49, 2.50. Again, this is the same 0 to 5 volt signal, except it's running through a bypass cap to remove the DC offset. In AC mode, this is reading 2.76 volts instead of 2.5. And if we were to read that same voltage with a true RMS meter like this Fluke 189, this will also read 2.5 volts. So 2.4879, that's a little low, but that's not the meter, that's actually my test box. So if we calculate for an averaging type meter, we would take pi over the square root of 8, again this is a square wave, so that's 1.1107, multiply that by our 2.48 volts, and that gives us 2.76 volts. So again, if we look at this signal with our Fluke, we can see it's 2.75 volts. Again, this is an averaging meter, just like the Harbor Freight. So if we take the same measurement with our Harbor Freight meter, this is the one area that the Harbor Freight meter doesn't do very well. You can see it only has a 200 volt range. That's the most sensitive. And you can see it reads 2.3 volts. So let's try a little bit higher voltage. Check this first with our 189, and you can see it's roughly 67 volts. And again, let's try that with the Harbor Freight meter. And we can see it displays 130.2. And let's try it with our Fluke meter. And we can see it's reading 68.8 volts. Now I would expect this to read roughly 74.4. What's probably happening is this is a pretty high frequency signal. This is running at about 3 kilohertz, and I doubt that the bandwidth on this meter is high enough to really look at this. So if you're using the 2 meters for electronics work, I would say at least for the AC performance, the Fluke is going to outperform this Harbor Freight meter. Let's go to resistance, and we'll start with a dead short. And you can see the Fluke reads 1.4 ohms. Now there's no zeroing function on this meter. It's the same thing with our Harbor Freight meter. Let's set this also to the 200 ohm scale. You can see it fluctuates quite a bit, but somewhere between 1.5 and 0.9 ohms. Again, the leads that they supply with this meter are not the greatest. Let's just check this with a 100 ohm resistor. So you can see 101.1. Again, this is a 0.01% part. Let's try it with our Fluke. And again, we can see it's 101.6. What you would want to do with this to get a fairly accurate measurement, you're going to have to manually write down that there's this 1.5 ohm offset and subtract that from your reading. And of course then we could see that this Fluke would be quite accurate. Let's just try it with a 1k ohm resistor. And you can see it's 1.001. And we can check it with the Harbor Freight meter as well. And we can see 1.006. Let's go to a 10k ohm. And it's reading 10.00 on the money. Again, this is a 1% part. And let's try it with our Harbor Freight meter. And again, 10.01 it looks like. Let's go to a 100k ohm. And we can see it's 100.3. Fairly accurate. Let's try it with our Fluke. And it's 100.0. A little more accurate. Let's go up to a 1 mega ohm resistor. This is a 1% device. Looks like 1 meg. So again, let's try it with our free Harbor Freight meter. Also has a 2000k ohm range. And there you have it. So dead on. Now, of course, the Harbor Freight meter has a diode check mode. So if we put the leads across a single silicon diode, and we can see it's 719 millivolts. So the way we'll do that measurement with the Fluke is we'll leave it in resistance, but we'll go to the 2K ohm range, and we can see 0.652, and if we flip the leads around, of course, nothing. Let's try 2 in series. So 1.3 for the people who want to see the LED light. Boy, you can see that's bright. Not sure what the open circuit voltage is with this particular meter. We can have a look real quick. So there you have it. About 14 volts open circuit with this meter. And we'll just change to milliamps. And there you have it. So about 1 milliamp of drive current at 14 volts. I doubt you're going to find very many handheld meters that would run up that high. Of course, the meter does have one other range for resistance, and that's the 20 mega ohm setting. So let's try it with a 10 mega ohm resistor. There you have it, 10.03 it looks like. And unfortunately the Harbor Freight meter can't run up that high. So let's switch over to current, and we'll go to DC, and this is the 200 microamp range. Again, we'll set 100 microamps with our test box, and there you have it. So roughly 98.1 microamps. And try the same test with our Harbor Freight meter. Again, this is in the 200 microamp setting, and we can see it reads 98.0. Fairly close. So again, both of these meters don't have any input protection. So again, to be very clear, there's no doubt in my mind about this meter's inability to handle some real basic transients. Of course, over the years I've shown where I've modified some of the meters that I've tested to try to make them more robust. And people will start asking me particulars about how I made those modifications, and of course I'm never going to be very forthcoming with that information. So if you're needing a more robust meter, again, I just suggest you go out and buy something like this Bryman BM869S. Even this old Fluke 189, again, I purchased this one just for the purpose of transient testing, and if you go back and look at the video on this, this meter is very solid, even for its age. Of course, every Fluke I've looked at has done quite well in my testing. So again, I made some models of a few different meters. This is the one for the Bryman BM869S. These are the 2 transistors that I used to replace the ones that I damaged in this particular meter. These make the meter a little bit more robust as far as running them on my transient generator. So what I thought I could do was basically build a circuit where you have your high surge rated resistor in series with a PTC, and then down to a MOV, and then just put that on an external board. So that's what I've got here. So you can see there's not only the single MOV, there's also this gas discharge tube. The tube in this case is rated for 600 volts. The MOV is rated for about 620. The idea being that this MOV will take the first hit, and if the transient stays up long enough, the gas discharge tube will eventually fire and then crowbar the output. So here we can see small PTC, and here's our surge rated resistor. So this would just plug into the front end of our meter like so, and then we could plug in our test leads to this board like so. In this case, again, the meter is rated for 1200 volts, and the MOV is rated for 620 versus the gas discharge tube at 600 volts. So it should be able to clamp it low enough to actually save the meter under a transient condition like a solenoid. Again, to be clear, I don't do any kind of work here on my bench with any sort of high energy circuits. You know, the high voltage isn't really an issue for most of what I do here because there is such a low energy involved. So from a hazardous standpoint, I'm not usually too concerned about it. If I play with currents that could be lethal, I typically take precautions. Even when I'm transient testing the meters, you can see that I'm usually not touching things, especially if I use that half cycle line simulator. I'm quite a ways away from the meter when I actually set that thing off. Okay, off to my left you can see I have one of our high voltage power supplies out. And here we have our clamp. Currently the output of this is attached to our Bryman meter. We use this for our initial testing, and that's because I know that this meter can handle 1000 volts. So let me go ahead and turn up the voltage and we'll see where the clamp starts to engage. Because it should be somewhere around 600 volts. Right there. Near the gas discharge tube firing. Basically for DC, until I remove the power supply, that's going to continue to fire that tube. Of course, the current is limited by the PTC and the resistor. This PTC is rated for about 1.4K. The resistor is obviously a 1K ohm resistor, so about 2.4K in series with this power supply. Of course, once the PTC begins to build heat, its resistance goes up, and that's going to limit our current. And again, the gas discharge tube is pretty slow, so what I'm hoping here is that the MOV is going to handle any of the high-speed transients. And again, that gas discharge tube is in there just to basically crowbar the output. So let's go ahead and we'll try this on the Fluke. Again, we'll place this in DC volts, and we'll set it to the 1200 volt setting. And let's go ahead and turn up our voltage. Again, there's 300, 400, 600, should be right about in here. Right there, it's firing. Let's just try to drive it deeper in, get that gas discharge tube to fire. There you go. See, it does a pretty good job limiting. So yeah, I think that's going to work fine as far as protecting this meter. Again, if you do damage one of these, the parts are not available. The only thing you could maybe do is find another donor meter, which again is what I had to do in the case of this particular meter. I ended up saving some of the parts out of the other meter. For example, one of the decimal places on my meter was out, so I scavenged the other meter for one of the LEDs. And of course the LED on the left is different than the other LEDs, so I ended up saving one each of those LEDs out of the old meter. So I ended up scavenging the old meter for some of the precision resistors and whatnot, some things I thought that maybe I could use later on. Well, I think that's going to be it for this video. Again, if you're just getting started, do you need a meter like this Bryman? My guess is probably not. Again, by the time I bought that first HP 3468A meter, I had been experimenting with electronics for a little over 10 years. But again, the kind of work that I was doing was not all that sophisticated. But again, if you're like me and your hobby expands and you start working on more complex things, maybe you need a meter that's more sensitive, higher resolution, and better accuracy. I certainly did. That's why I bought the bench meter in the first place. But would I recommend something like that to somebody who's just starting out, or somebody who's maybe doing repair work on dishwashers, or checking some home wiring or something? No, I definitely would not. Again, that's why it's really up to you to make your own decision as far as what you need for test equipment to do the work that you want to do. So I've got a couple of videos planned for the near future. I've got a new meter that I want to look at, but I've also got another test that's been ongoing for about the last 3 months now. That's probably about another month out before I decide that I'm giving up with that particular test. I also made up a new test fixture that I hope to be showing in the next video as well, so stay tuned for that. So I'd like to welcome all you new followers. It wasn't that long ago, we were only at like 2,000 followers. Looks like we're now at over 8,000. People just keep joining up. It's kind of surprising to me because this is kind of a specialized channel. So for whatever your reasons are for being here, welcome, and I hope you enjoy the videos. Well, all for now. Till the next video. Later.